Good day, grade 10 learners. Welcome to our mathematics lesson. I am Skulile Ngube, and this lesson is proudly brought to you by the Gauteng Department of Education. Right, grade 10s, we have to be ready for our lesson. Today, we're dealing with special angles, still doing our trigonometry. Right, you remember that? What have we covered in trigonometry? We talk about the trigonometric ratios, and then we talked about the reciprocals of the trigonometric ratios. We talked about the angles in the Cartesian plane. Remember that? Pattern 1, 2, 3, 4. And then today we're going to look at special angles. We're going to look at special angles and how the ratio of these special angles are derived. Okay? Especially the 45 degrees, the 30 degrees, and the 60 degrees. And then the other ones, I'm going to mention them, just give you notes. Okay? Right. So today, grade 10s, you are going to do a lot of calculations. Let me tell you that. We are going to spend almost 40 minutes of our 60 minutes doing calculations. So be ready. Make sure that you have your book with you. And I'm going to be asking you, do this calculation. You do it, then we mark. Isn't it? Like we usually do. Let's be ready for our lesson. Right, let's start. So special angles. What are we going to learn? By the end of the lesson, you should be able to derive values of trigonometric ratios for special angles without using a calculator. So what about 0 degrees is a special angle, 30 degrees is a special angle, 45 degrees is a special angle, 60 degrees is a special angle, and then 90 degrees is a special angle. Right. Also, we're going to talk about 180 degrees, 270 degrees, and 360 degrees. Right. But deriving, we're going to see how the values of the trigonometric ratios, like say sine 30, cos 30, tan 30 is what derived. And then also we'll talk about the 45 degree one and then the 60 degree one. Okay. Right. Let's go straight to our lesson. We've done these concepts in grade 8 and 9. Even in some of them, we did them in grade 10. We're going to use them a lot. Our knowledge about triangles. What do you know about isosceles triangles, equilateral triangles, right? Right angle triangles. Which theorem do we use most of the times when you talk about right angle triangles? The Pythagoras theorem. Remember the Pythagoras theorem. Our knowledge about trigonometric ratios. Sine theta, opposite side over hypotenuse. Cos theta, adjacent side over hypotenuse. Tan theta is opposite side over adjacent side. Remember that. And then on knowledge about squares, square roots, cubes, and cube roots. We are going to use these concepts a lot in this lesson. Right. So this is very, very crucial. I want you to try this baseline activity. And let me give you 3 minutes. Simplify the following if possible, if possible. If it's not possible, we leave it as it is. So it's A, B, and C. Let's do this in 3 minutes. Right, welcome back, cretins. This is very, very simple. Very simple. Right, it's like simplifying sets. Right, remember, cretins, our WhatsApp line 063 629 3655. Let's engage each other during the lesson. So, right, square root of 5 and square root of 5. These are like terms, just like we deal with x plus x. What is x plus x? X plus x is equal to 2x, isn't it? So it is the same thing here. Root 5 plus root 5 is equal to 2 root 5. Okay? Right. And then square root of 3 plus square root of 5. These are unlike terms. It's like unlike terms. We say x plus y. X plus y is x plus y. So we leave it as it is. So it's still square root of 3 plus the square root of 5. And then 3 times square root of 2 minus square root of 2, it will be the same thing as, maybe let me say, 3x minus x, isn't it? There's an invisible 1 here. So it's like 3x minus 1x. Like here it's going to be 3 root 2 minus 1 root 2. What do we get? We must get 2 root 2. So we treat this as like terms if they are the same. If they are different, we treat them like unlike terms. Okay? Right, I have 3 questions on the baseline. Let's do the next one. Right, the next one. We're simplifying A and B. How many minutes do we need here? Let's say 2 minutes, 1 minute for each. 2 minutes. Let's try. Right, welcome back, cretins. Let's see, what did you do? Square root of 2 times square root of 3. How do we simplify this? Remember that square root of a times square root of b is just the same as square root of ab. See that? Square root of a times square root of b is just the same as square root of ab. So here, square root of 2 times square root of 3 is just the same as square root of 2 times 3. Remember, ab means a times b, isn't it? So it's going to be square root of 6. Right? And then, if we square a square root, what do we get? Like here, we're squaring a square root of 3. What will you get? We're going to get 3. Remember that the square root and the square, they cancel each other out. So we remain with 3. Okay? We remain with 3 there. Right. Then the next one, I want you to do A for 2 minutes, and then we'll discuss A. And then after discussing A, you do B. But if you know how to do it for both A and B, continue to everything, okay? But let's say you don't have an idea on what you're supposed to do, just wait for me. I'll explain A, then I'll give you time to try B. Okay, let's start with A for 2 minutes. Rationalize the denominators. Okay, so rationalize the denominator for 2. Right, welcome back, great 10th. Right, what type of a number is square root of 2? What type of a number is it? You have done the number system, isn't it? You know rational and irrational numbers. So sets are what? Sets are irrational. So sets are irrational. So it means the square root of 2 is irrational. But now we're asked to rationalize it. It means it must be rational. Right, what type of numbers are rational? Remember, integers are rational, terminating decimals are rational, recurring decimals are rational, isn't it? So we can make this square root of 2 become rational. What can we do? Remember, in the previous activity, we said that root 3 times root 3 is equal to 3, isn't it? So now it means here, if you say root 2 times square root of 2 will give us 2. So we can multiply the denominator by square root of 2. But if we do that, we have to do the same thing to the numerator. If we multiply the denominator by square root of 2, we must multiply the numerator also by square root of 2. You see that? This is how we rationalize denominators. And then we say, you see that we have multiplied the denominator by square root of 2. We are going to multiply the numerator by square root of 2. And then square root of 2 times square root of 2 will give us 2, which is an integer, which is rational. Now the denominator has been rationalized. Okay, so this fraction and this fraction are just the same thing. They are equivalent fractions. We have multiplied the denominator and the numerator by the same thing. You see that? So this is now rationalized. We have rationalized the denominator. We're going to apply this concept in this lesson. That's why I want you to understand. Right now, I want you to rationalize this expression on B. I'm going to give you 1 minute to do that. Rationalize this one. 1 minute. Let's try. Remember our WhatsApp line, grade 10 063 629 3655. You got this one right, isn't it? Very good. What did you get? So we multiply the denominator by square root of 3, and then we have to multiply the numerator by square root of 3. Do you see that? Okay. And then what is square root of 3 times square root of 3? It will give us 3. Then 2 times square root of 3 is 2 root 3. Now we have rationalized our denominator is now 3, which is an integer. So this fraction and this fraction, they are the same, but this one is what? A rational denominator. Okay, now we've done our baseline activity that we're going to, and the concepts that we have discussed, we're going to use them in our lesson. Remember our lesson, we want to derive the trigonometric ratios for special angles. We're going to start with angle 45 degrees. Right, special angles, these are the angles, we talked about these ones, and then angle 45 degrees. Right, so what do we do here? We have to use our triangles. We have to use our triangles. Remember, Cretans, you have to know how to derive these trigonometric ratios for what? For special angles. So we have to use our triangles. And then which triangle do we use? We use a what? An isosceles triangle. Actually, a right-angled triangle which is isosceles. Right-angled isosceles triangle. Right? Why right-angled? Because it is a 90-degree angle. B is 90 degrees there. And then why isosceles? AB and BC are equal. Okay. Remember, an isosceles triangle is what? 2 equal sides. And then you have to remember 2 equal sides. And then angles opposite equal sides are equal. And then sides opposite equal angles are equal. That's an isosceles triangle. Right. Now, I want us to use this triangle. Let me give you 1 minute to just sketch this triangle ABC, and then you write the side AB is equal to 1, BC is equal to 1, and angle B, indicate that angle B is what? It's a right angled, it's a right angle, sorry. Angle B is a right angle. Just 1 minute to draw the triangle ABC. Right, I really hope you've managed to draw your triangle. Please, if you haven't finished, continue, finish fast so that, because we're going to be writing the angles here on the triangle, so it is very important that you draw the diagram. So now, find the size of angle A and C. I want you to try that. I'm going to give you 2 minutes to try that, and then after 2 minutes, we're going to discuss, and then we do it together. Don't stress if you don't know it. Just try. Just try, and then after 2 minutes, I'm going to give you the answers. Let's find the size of angle A and angle C. This angle and this angle. Let's try to do that for 2 minutes. Right, welcome back, Cretans. Thanks very much, Lamula Secondary. Oh, sorry, it's Lamula Jubilee Secondary School. Thank you very much for your input. I will try to slow down so that we understand, isn't it? Please feel free. If there's something you missed, let us know. I will go back and we discuss whatever you have missed. Please let us know. Just be specific. Say, I didn't understand that part. Then we'll go back there and what? And we discuss that. Thank you very much for your input. Let me slow down a bit. Right. Find the size of angle A and angle C. Now we have to apply our knowledge about Euclidean geometry, isn't it? Right. We have to apply our knowledge about Euclidean geometry. So what do you know about these angle A and C? They are equal because BC and AB are equal sides. Okay. And then what do you know about angles of a triangle? The interior angles of a triangle must add up to 180 degrees. Okay, right, let me write here because the method that I have here is going to be very, very, it's like a shortcut thing. Let me explain step by step. So if we say angle A plus angle B plus angle C, what do we get? Angle A plus angle B plus angle C, what do we get? Angles of a triangle add up to, interior angles of a triangle add up to 180 degrees, okay? 180 degrees. Let's not forget our reason. So we say angle sum in triangle. Angle sum in triangle. So if we add these angles, we what? We must get 180 degrees. Angle B is 90 degrees, isn't it? This is angle B. It's 90 degrees because it's a right angle. But A and B, A and C are what? Not A and B. A and C are what? Are equal. This angle and this angle are equal. I hope I didn't say A and B are equal in one of the people, okay? So A and C are equal. A and C are equal, right? And then so we can say, but angle A is equal to angle C because these are angles opposite equal sides. Okay, you did this in grade 9, okay? All right, so angle A and angle C are equal. So it means we can replace angle C here with A because they're equal, isn't it? So it's going to be A plus A. I'm saying angle C is equal to A, isn't it? So A plus A is 2A, isn't it? 2A coming from A plus C there. And then plus B. B is what? 90 degrees is equal to 180 degrees. Do you understand that part? Okay, I said angle C is equal to angle A. So where there's C, I can put A, angle A. Then if I say A plus A, I get 2A. Okay? And then B is 90 degrees. Then we subtract 90 from both sides of the equation. So angle 2A, so 2 angle A is equal to 180 degrees minus 90. What is it? It's 90 degrees. Okay. Okay. And then, or we can write it in full and say 180 degrees minus 90 degrees. Still fine. And then what do we do to get angle A? We divide by 2 on both sides of the equation. So angle A is equal to 180 degrees minus 90 degrees divided by 2, which is the part that I just went straight to. I just went straight to this part. You see that? Okay, which is just this. Okay, all right, that's where it is coming from. And then 180 degrees minus 90 degrees is 90 degrees. Then 90 degrees divided by 2 is 45 degrees. So it means that angle A and angle C are both equal to 45 degrees. Okay, all right. Now, let me clear the ink. All right, so we're saying these angles are equal to 45 degrees. I'll give you 1 minute to fill the diagram. Don't write a lot of things. Just our diagram, make sure you write your angle A is equal to 45 degrees and then angle C is equal to 45 degrees. Let's do that on the diagram that you drew in the previous part when I asked you to draw the diagram. Don't draw a new diagram. Okay, let's do that in 1 minute. Grade 10s, I want us to continue from here. Remember our objective. Let's not forget our objective. What do we want to do? We want to derive the trigonometric ratios of this angle 45 degrees. So if we take this angle as our reference angle, we have the adjacent side, which is 1 unit. We have the opposite side, which is 1 unit. But what is missing? We want the trigonometric ratios. Which side is missing? The hypotenuse, AC. So now I'm going to, because of time, I'm going to explain how we get AC. I'm going to explain how we get AC, and then I'll give you time to write what? To write your notes. Okay, let's do that. Now, ABC is a right angle triangle. So how can we find AC? We use the Pythagoras theorem. What does it say? Now, AC squared is equal to AB squared plus BC squared. That's the Pythagoras theorem. The hypotenuse squared is equal to the sum of the squares of the other two sides. Okay, so it's AC, which is the hypotenuse, squared is equal to AB squared plus BC squared. And then we substitute our AB and BC. What do we get? AC squared is equal to 1 squared plus 1 squared. Okay, right. And then, what is 1 squared plus 1 squared? 1 squared is 1. It means AC squared is equal to 2. And then what do we do to get AC? We square root both sides. It's going to be AC squared square root is equal to 2 square root. And then what is the square root of AC squared? We talked about this in our baseline activity. The square root and the square, they cancel each other out. Then we remain with AC is equal to square root of 2. So AC is equal to square root of 2. And then means AC there is square root of 2. Okay, on our diagram. Now, let me give you 1 minute to write your short notes. And then after that, we're going to continue. Right, welcome back, grade 10s. Remember our WhatsApp line 063-629-3655. If there's something that you missed, please let us know. Right, now we have our triangle ABC with all the 3 sides and the angles. Right, Now you pick any angle. Let's say, oh, just the same. C and A is just 45, 45. So we can pick any. Maybe let's say this one as our reference angle. I want you to write the trigonometric ratios in terms of this triangle. Okay, what is sine 45, cos 45, tan 45? Remember, SOHCAHTOA. Okay, what is sine 45, cos 45, tan 45? Let me give you 2 minutes. Then after 2 minutes, we're going to mark our work. Let's try. Right, welcome back, grade 10s. Let's continue with our lesson. Right, sine 45 is opposite over hypotenuse. Opposite is 1, hypotenuse is square root of 2. And then it's 1 over square root of 2. And then if we rationalize this, what do we get? 1 over root 2, we say times root 2 over root 2. Okay, times root 2 over root 2. And then 1 times root 2 is root 2. And then root 2 times root 2 is 2. See that? We have rationalized. See that? Okay, so that's our answer there. Then cos 45 is adjacent side over hypotenuse. So adjacent side is 1, hypotenuse is square root of 2. So it means it's 1 over square root of 2. Then let's rationalize our denominator. It's going to be the same, isn't it? It's going to be the same. So it's going to be square root of 2 over 2. Just the same as this. Okay? Then tan 45, opposite side over adjacent side. This is the opposite side for this angle 45. This is the adjacent side. So it is 1 over 1. What is 1 divided by 1? It is 1. You can use your calculator and check. Just say tan 45. You see 1. You get 1. Or cos 45. You get root 2 over 2. Sin 45. Root 2 over 2. Okay? Right. Now, these are the trigonometric ratios for the angle 45 degrees. Which angles are we left with? We have to do the 30 degrees and the 60 degrees. Okay, so these two are going to use the same diagram. Right, let's go there. Angle 60 degrees and 30. Oh, I didn't give you time to write notes. Let me go back. Right, just 1 minute. 1 minute to write notes. Right, welcome back, Cretans. Let's go to the angle 30 degrees and 60 degrees. Now, because of the time factor, I'm going to explain and then give you time to write notes, okay? And then I'm going to give you the activity when you are writing the ratios, isn't it? Right? The other part, I'm just going to explain, then give you time to write notes, okay? Right. Consider triangle ABC, which is equilateral triangle. Do you know the properties of an equilateral triangle? All the three sides are equal, all the three interior angles are equal. And then if they are equal, interior angles, remember the interior angles of a triangle add up to 180 degrees. So if the interior angles are equal, we just say 180 degrees divided by 3. And then each angle is 60 degrees. 60 degrees plus 60 degrees plus 60 degrees must give us 180 degrees. Okay, so we have the triangle, equilateral triangle with all the angles there equal to 60 degrees. And then the sides, we're going to use 2 units for each side. AB is 2 units, AC is 2 units, and then BC is 2 units. And then each angle is 60 degrees, isn't it? Right. Each angle is 60 degrees. Now I want you to copy this triangle, equilateral triangle, for 1 minute. Okay, let's do that. Copy the triangle for 1 minute. Let's try. Right, welcome back. If you're still drawing the triangle, please continue. Please continue. We're drawing the triangle ABC, an equilateral triangle. Right. We want to prove the ratios for the 30-degree angle and the 60-degree angle. So this triangle we're going to use for both the angles. Right, the next step, we'll have to do a construction. Just drawing a line. So we're going to construct AD, the perpendicular height of triangle ABC. So we're going to draw AD, which is the perpendicular height of triangle ABC, like this. And then let's do that. Okay, let me explain everything, then we'll write our notes once. Right, this line AD, or this point D, is the midpoint of BC. It means it divides BC into 2 equal parts, meaning that BD is going to be 1 unit and DC is going to be 1 unit. And then the other thing, this angle is also 90 degrees. Remember, angles on what? On a straight line. Adjacent angles on a straight line add up to 180 degrees. If this angle is 90 degrees, this angle is also 90 degrees. Then what will be the size of this angle? BAD. What will be the size of this angle? CAD. What do you think it's going to be? Right. The other thing, maybe if you didn't know this, if you have a right angle triangle, like this is a 90-degree angle. These 2 angles, let me name them, P, Q, R. Right, these 2 angles, in this case, Q and R, are complementary angles. What are complementary angles? Complementary angles add up to 90 degrees. So these 2 angles must add up to 90 degrees. Q and R must add up to 90 degrees. Meaning that if Q is 60 degrees, R must be 30 degrees. They must add up to 90 degrees every time. If Q is 45 degrees, R is 45 degrees. If Q is 20 degrees, R is 70 degrees. If Q is 10 degrees, R is 80 degrees. Every time they must add up to 90 degrees. They are complementary angles. Or you can even use the interior angles in a triangle. If you say this is a triangle, then you say 60 plus 90, that is 150 degrees. And then 180 minus 150 degrees, that's 30 degrees. See that? So this angle here is 30 degrees. BAC, BAD, not BAC. BAD is 30 degrees. Okay? Right, so BAD is 30 degrees. You can see 60 plus 30, that is 90. They are complementary angles. Or even if you use the interior angles in a triangle, you see that you will get 30 degrees. Okay? Right. Now, and then what about CAD? Angle CAD. It is also 30 degrees. Same explanation. Same explanation. Okay? And then I'll give you time to write notes once. And then we've discussed the BD issue and DC issue. We said BD is 1 unit. And then DC is also 1 unit. Okay? Right. I want you to draw the diagram now. Just add to your diagram that you drew. Add this extra information that we have just added. The angle 30 degrees there. For BAD 30 degrees, CAD 30 degrees, and then BD 1 unit, DC 1 unit. Let's do that, and then in our next part, or after that, we're going to find the side AD. Let's copy the diagram, or let's fill in our diagram just for 1 minute. Right, welcome back, great hands. Let's look at this triangle. It's a right angle triangle, isn't it? Triangle ADC. Okay. We know DC is 1 unit. We know AC is 2 units. What about AD? What are we going to do? We use the Pythagoras theorem. And the Pythagoras theorem does not change. It's always the hypotenuse, which is AC squared, is equal to the sum of the squares of the other two sides. So it's equal to DC squared plus AD squared. And then you write your reason Pythagoras. Let me just write pi because of space there. Write your reason Pythagoras. And then we want AD squared. So what must we do? We must subtract DC squared from both sides of the equation. So it's AC squared minus DC squared is equal to AD squared. And then some people, when they're finding this side, they just come straight to this equation there. Okay, which is what I have there. You see that? So AD squared is equal to AC squared minus DC squared. Okay, we have our AC, which is 2 units. We have our DC, which is 1 unit. So it becomes AD squared is equal to 4 minus 1. AD squared is equal to 4 minus 1, meaning that AD squared is equal to 3. AD squared first is equal to 3. And then what do? We square root. Square root of AD squared, we get AD. then square root of 3, we get square root of 3. So 80 is square root of 3. Okay, right, let me erase the ink, then you can fill in more information for 1 minute, then we continue from there. Right, let's fill in the information, especially all the sides. All the sides of the triangles must be there. AC, DC, AD must be there. Even AB and BD must be there. Even your angles, BAD must be there 30 degrees. CAD must be there 30 degrees. And then these ones also 60 degrees and 60 degrees, they must be there. Let's say for 1 minute, let's fill in the information, then continue from there. Right, welcome back, grade 10s. Let's continue now. Now we have our triangles. I want you now to write the trigonometric ratios: sine 30 degrees, cos 30 degrees, tan 30 degrees for 2 minutes. We are using angle 30. So if you choose to use this triangle, for example, let me highlight the triangle for you. You can use it. Okay. If you want to use the one on the right hand side also, it's still fine. But your reference angle is 30 degrees. And remember your SOHCAHTOA. Okay? Right, SOHCAHTOA. Right, let's fill in what is sine 30, cos 30, tan 30. Let's try that in 2 minutes. Right, welcome back, grade 10s. Let's mark our work. SOHCAHTOA. Sine 30 is going to be opposite of hypotenuse. The opposite is 1. Hypotenuse is 2. This is 1 over 2. Mark your work. And then cos sine 30, adjacent over hypotenuse, adjacent is root 3, and then adjacent over hypotenuse, adjacent is root 3, hypotenuse is 2, so it's root 3 over 2. Mark your work. And then tan 30 is opposite of adjacent. Opposite is 1, adjacent is root 3, so it's 1 over root 3. But we have to rationalize our denominator. So it's going to be root 3 over 3. Okay? Right. So 1 minute, write your notes, and then we continue. We have to do the angle 60 degrees, then we'll be done. Right, 1 minute for your notes. Right, welcome back, grade 10s. I really hope you managed to get those questions correctly. Right, I will explain the angle 60 degrees, then you write your notes, and then after that we summarize our lesson, okay? All right, let's go to angle 60 degrees. Let's choose which side. Let me choose this side, this triangle. All right, and then 60 degrees now is our reference angle. We want angle 60 degrees. And then sine 60 degrees is opposite over hypotenuse. Opposite is root 3, then hypotenuse is 2. So it means it's going to be root 3 over 2. If you can try to be ahead of me, try to do that and then mark your work after I've given you the answer. Cos 60 degrees. Cos 60 degrees would be adjacent over hypotenuse. Adjacent over hypotenuse, and then it's 1 over 2. What do you recognize about cos 60 degrees and sine 30 degrees? They are equal. Remember, sine 30 degrees, check your notes. Sine 30 degrees is also 1 over 2. Cos 60 degrees is 1 over 2. And then this one. Sine 60 degrees is root 3 over 2. And then cos 30 degrees is root 3 over 2. If you check, you can see that, okay? Yes, you can check that. And then tan 60 is opposite over adjacent. It means it's root 3 over 1, which is basically root 3, okay? Right. Now, 1 minute to write your notes, and then after that, after 1 minute, we'll just take a short break after 1 minute, and then we summarize. 1 minute. Right, welcome back, grade 10. Let's summarize our lesson. What did we learn? We said sine 30 is 1 over 2. Then cos 30 is root 3 over 2. And then tan 30 is root 3 over 3. And then these ones, you have to know that sine 0 is 0, cos 0 is 1, and then tan 0 degrees is 0. Right, we talked about sine 45. Say sine 45, we have to rationalize this and get root 2 over 2. And then again here, root 2 over 2. And then tan 45 is 1. And then we had 60 degrees, said sine 60 is root 3 over 2. And then cos 60 is 1 over 2. And then tan 60 degrees is root 3. Okay, that's what we learned in this lesson. Right, thank you very much, grade 10s, for joining us. We are going to meet in our next lesson. Enjoy the rest of your day and also have a good rest during your holidays. Thank you very much. Goodbye.